So next point was insulation. So let's take thermal insulation first. Thermal insulation. Suppose we are going to construct the wall in a place like Jodhpur, even in Delhi. So let's say day temperature is 45 in Jodhpur, 45 degrees Celsius during daytime. Night time it would be suppose 25 degrees Celsius. So that means diagonal range of temperature is quite high. Daytime we are having 25, nighttime 20. Sorry, daytime we are getting 45, 25. But if you look at Andaman Nicobar, let's say, so daytime you may have 27 degree, nighttime you may have 25 degrees Celsius. Even throughout the year, the variation will not be very high. So obviously the sectional detail of the wall will be different. So let's see what are the various indexes that we can really use. Again, there are a lot of indexes, but we'll discuss very few of them. So U factor you will find very frequently. Another is thermal time constant, thermal performance index, or another could be time lag or thermal damping. So don't worry about this various terminology. There are other terminology also. So don't worry about this various terminology. We will not discuss in detail each and every terminology. Few things we can discuss in BR course, right? If someone is interested in research, they can go for that. Lot of research is going on thermal insulation of the building, or the energy saving in the building. Now this U factor very frequently you will find. Thermal damping is also very important phenomenon. All things are important. BMTPC, Building Material Technology Promotion Council. You will find lot of material are introduced by BMTPC also, and very good materials there. Thermal transmittance. Again, we will not discuss in detail. So, for example, we have the wall. Outside temperature is 40 degrees Celsius. Inside you do not want 40 degree. Obviously you want to cut the temperature, right? You want 30 degree or 28 degrees Celsius or something like that. So obviously if thickness will be more, the U factor will be less. U factor is thermal transmittance. How the heat is going to transfer through the wall. We draw the section. Suppose this is brick wall, 230 mm thick brick wall. Outside temperature is 40 degrees Celsius. Obviously heat will transfer through the wall, and you want 25 degree or maybe 30 degrees Celsius. So the more the thickness, the lesser U value, the less heat is going to transfer, right? So that is U value. Another term is thermal damping. That means, again let's take an example for any like Jodhpur city or desert area. So daytime you are getting 45 degrees Celsius, right? Night time you are getting 25 degrees Celsius. I am talking about outside temperature, but inside you do not want that much high, and inside also 25 is not required. So for example, so difference is around 20 degrees Celsius, but let's take the inside temperature. So let's take 30 degrees. Suppose in the night time the inside temperature, this is outside, this is inside. So inside night time we are having 30 degrees Celsius, and daytime we are having 35 degrees Celsius, right? So thermal damping will be, the difference is 20 outside, inside temperature difference, daytime and nighttime is 5. If you divide by 20, so almost 75% damping you are getting, and that is quite good. So that is thermal damping. Yeah? So if the diurnal temperature is high, the thermal damping play a major role. If outside temperature is high but diurnal temperature is not very high, U factors plays a major role. So these are various factors that we can think of, we should think of. Right? And another is thermal time constant, thermal performance index. Time lag is also in terms of peak temperature. For example, outside peak temperature is 45 degree at 2 p.m. and inside the peak temperature is around 4, 5, 6 p.m. The more the thickness of the wall, the time lag will be more. Anyways, what was the other point? The next point? Sound insulation, right? Third point was by the way, cavity wall perform very well in case of thermal insulation as well as sound insulation. Cavity wall means you will construct a wall, then this will be we will have air cavity, and then we can have another layer of wall. And obviously at some point you will have tie also, right? You can keep some gap over here also. It will depend how you are going to design and what is the purpose for designing. So anyways, so for sound insulation, what were the parameters that we have noted down earlier? TL, transmission loss, another was STC, sound transmission class. There are other parameters also, but we will not discuss in detail, and lot of things are there. So that we will study in our acoustic class. Probably I will be teaching in 4th semester this acoustic subject. Anyways, so TL was transmission loss. Suppose we have wall here and outside sound level is suppose 80 dBA. We'll discuss what is dBA in detail. Don't worry here. So 80 dB sound is there. Even in our classroom also, if you see beyond the wall there is highway, right, and very noisy highway that is. So generally, if you measure nearby highway, you will get 80 dB, even more than that, 85, 90 dB of sound. But average sound would be around 80 or 75. Now, inside we do not want that much of noise level or sound level. So inside, suppose we are getting 40 dB, or suppose we are having 50 dB. So that means there is loss of 30 dB. So transmission loss will be here 30 dB. Suppose you have a room, you have partition wall. We have also partition wall, right? Firstly we have partition wall, then we have section C. Suppose we have partition wall made up of this timber or any plywood. So some noise is here, some kind of noise is here. We do not want to cross the noise. So in that case, if you purchase this material, you will find STC rating, sound transmission class. So this would be more if you want to reduce the sound much. There is some difference that we'll discuss later, because the transmission loss also depends on various frequency of sound. So this is kind of average of this. But anyways, let's not get into detail. Apart from STC, suppose we have this plywood wall, right? This is our class section A, and we have section B. So there is some noise is here, some noise. We do not want to cross the noise from here to here, or either vice versa. Now thickness of this plywood, suppose 2 inch we are having, and STC rating is 5. So obviously if we increase the thickness, the STC will be more and that performance will be good. But another thing is, the very interesting thing is, we have 2 inch thick plywood. Now stiffness also matters. Again, we will not discuss in detail, but in acoustic class we will discuss in detail in 4th semester. But if we increase the thickness, STC value will be more. Now stiffness also matters. We make some groove over here. So now this will become less stiff. Only we have 5 decibel sound is going to be reduced. Now I have made some groove and this became less stiff. So what do you think? The STC value will be more or less? Because of this groove, stiffness will be less. This will be more flexible. Now we can achieve up to 15 dB of sound, reduction of sound. So again, we will not discuss in detail here. Now another very interesting thing is, whenever you get time, you can search on YouTube the quietest place on the earth. So you'll find there is a laboratory. I'm forgetting the name of that lab, and that is old video. Now we have lab in our IITs also. So in that lab, the inside, suppose this is the lab, this is the, so inside the lab, the level of sound was minus 9 decibel. Again, don't worry about this negative thing, we'll discuss in acoustic class. That was the world record for that time, the minimum level of sound inside that level. Now if you generally measure in mobile also, we have the sound level meter. If you measure at the night also, generally minimum you may find around 30 dB. So that is quite good condition. Now tell me, what should be our preference? Should we make the room in such a manner inside the sound level will be too less, or there should be some range in between? What do you think? The thing is, the more silence we have, the more comfortable we will be. But that is not true. If we have too much of silence, that is also not very desirable, and that will be termed as dead space. So there should be some sound. Firstly, the world record was the quietest, the lowest level of sound inside the room, inside the lab. Another record was the person who stayed inside the lab for maximum 45 minutes or something. That was the record. And they don't feel comfortable inside the lab because of too much of silence. So tell me, what could be the reason of this, the second record? The person cannot stay for more than 30 or 40 minutes inside the lab. The problem of silence was that inside the lab, you may not hear any sound, but you can hear the heartbeat. You can also hear the movement of your blood. You can also feel the breathing, heartbeat, and that was not very comfortable inside the lab. So too much of silence is also not very good. So we need some kind of sound and noise, right? Now after this, what was the next point? Light transmittance. This does not matter much. Suppose you are using a brick wall or concrete or any bamboo or timber. If we are using translucent material or transparent material, then light transmittance matter. For example, if we are using glass brick, so there will be some light transmittance. Even in concrete also, we have translucent concrete also. So for glass brick, there will be some light transmittance value. I am not able to recall. You can check it, or around 0.6 or something you will get the light transmission, visible light transmission actually. Another term is SHGC, solar heat gain coefficient. So in glass brick it would be a little bit maybe more or something. So what is SHGC is, suppose you have this glass or any other material and solar radiation is hitting. So suppose you have 100, 70% is going to cross or 30% is absorbed or reflected back. So value will be here 0.7. How much solar radiation is passing through this material. So that is SHGC value. and we'll discuss in detail when you will study the glass, maybe second year or third year. So mostly when we discuss about glass or window, then SLGC value and VL visible light transference we discuss. Now, what is the next point?